everyone. Thank you first to Rajiv so much for giving us the opportunity to work on this project over the semester. We are, as Rajiv mentioned, the CSL team for HRI. This semester, it's me, I'm Zahir, by the way, here with Lisa, Arohi, and Win. This semester, the Honda team had challenged us to explore how AI can impact the future of mobility. So the goal for the semester was to utilize machine learning and large language models to sort of understand how mobility patterns can, use them to understand mobility patterns, and give the Honda Research Institute a generalizable pipeline that can create mobility insights on any given data set. This would allow HRI to ideate and incubate innovative solutions.
So this is kind of like a big picture overview of what we've been working throughout the semester to get to our MVP. So we use 4 different types of large language models, including GPT 3.5, GPT-4, Llama, and Mixtral. With those, we were trying to answer 8 different answer types, and then we got to that through 300 prompt iterations, 20 plus meetings, 50 plus hours, and at the end, we just ended with 5 user interviews to make sure that the product was working well. And so this leads us to our MVP. So we've called it Journ AI, and it's essentially a dashboard that provides an interactive framework in which people can generate, validate, and pitch mobility services ideas given any given mobility data set.
Our approach to Journ AI is pretty simple. Given any input data set paired with human-in-the-loop parameter selection, we employ AutoML-based clustering algorithms to form groups about mobility patterns, which then continue on to fuel a generative AI model that crafts interesting outputs like user personas, user stories, the CSL canvas, and much more.
And so here's an example or a screenshot of the UI where a non-technical person can simply click to generate clusters based on people's mobility and traveling patterns, and chat with the dataset to learn more information on the dataset, generate some user stories, and ideate potential solutions. Where here's just a very high-level overview of the architecture that we've designed, where as mentioned, we're able to generate insights using any unseen data set, where we're a firm believer in having a human in the loop, where in this case, an HRI researcher will be selecting parameters of interest, a Gen AI model will be expanding to adjacent parameters, where from that point, we're relying on classical ML, so techniques like MBA and HDB scan to convert data to information. After that point, we're passing the data and information into a series of LLMs, both in parallel and in sequence, where the goal here is to get to a number of outputs, so the 8 outputs that we've mentioned earlier. And we've stuck to best LLM practices, so some of the techniques that we've used here include just effective prompt engineering that was mentioned quite a few times today, also chain of thought reasoning, self-consistency, specificity and clarity. We've also relied on multi-agentic planning, so just getting a number of LLMs to interact and improve the responses as we go further down the pipeline, where as a result, we're able to generate insights about people's mobility patterns and potential solutions that's going to allow HRI researchers to iterate on ideas significantly faster. As a final note, I'd like to thank our clients Rajiv and Ryan at HRI, the CSL teaching team and staff, as well as my teammates. Thank you.